So we are discussing 1.7, and the next part of this section deals with the algebra functions, so combining two functions into one. So this page here is discussing if you were to add, so you can add the two functions together, that is the sum. So if you take function f and function g and you add them together, this is the notation. You'll see f plus g of x. And then there's the difference. So that's the subtraction. You subtract the function that is after the subtraction sign. There is the product. Product is multiplication. So it's the end result of multiplying two together. And then there's the quotient, where you take one function and divide by the other. Now, it says here that the domain are the set of all real numbers common to the domains of f and g. It's the intersection. The domain of f is the intersection of the domain of g. So let's take a look at some examples of these. So we have one right here where it says here's f of x, here's g of x, and then it says find each of the following. So it looks like actually one part is missing here. It should say f plus g of x. So find that. So to find f plus g of x, the sum of it would mean you're going to take f of x and add g of x to it. So f of x is right here. And so that's what I'm going to put in place of this. And g of x is right here. And that's what I'm going to put in place of this. So let's do that together. So f of x is the same as the expression x minus 5, or x minus 5. And then I'm going to add it to g of x. And g of x is the expression x squared minus 1. And then I'm going to combine any like terms. So in the case here, when I add them together, I'm just going to write them in descending order, which means the highest exponent to the lowest. There's nothing to combine. There are no like terms with the x. This is x squared and this is x, so they don't combine any further. But the two numbers will combine. So I can combine the -5 and the -1. And I'll combine those two to get -6. So when I add the two functions together, I get this. And then it says the domain of the sum. So the domain of f of x, so we have to look at the domain of each one. We have to look at the domain of g of x. And so the domain of f of x would be all real numbers, because remember, we learned that the only things that we need to exclude will assume all real numbers, except if x is in a denominator, which there's no x in a denominator, or if x is under a radical sign, and x is not under a radical sign. So then both of these have domains that are all real numbers. So the domain of this will be the intersection of these two up here. And since they are the same, then the intersection would be the same too. The intersection is where they overlap. Think of it like this. If this circle on the left represented the domain of f of x. Now, I'm not saying in this case it does. And this circle represented the domain of g of x. So let's put some colors on here. So the pink is the domain of F. And this purple part, I'm sorry, the blue part is the domain of G of X. Well, where they overlap in the purple part would be the intersection. So this is the domain of F, and the domain intersect the domain of G. So, excuse me, if you have, in this case, the whole thing's overlap because they share the same domain. But if you had where they overlap would be the domain of the algebraic, the addition, or any of the algebraic functions. It's the intersection. Now, with this one, it does not, this example here, the domain is not going to change. So it's only if you had one that was a square root or one that had x in the denominator. But let's look at, let's put another letter up here, and let's say it said f minus g. Well, f minus g would mean I take f of x and I subtract g of x. So f of x is what I highlighted in blue. So it is x minus 5. And g of x is what I highlighted in yellow. So it is x squared minus 1. But this time, instead of addition, we have the subtraction of the second function. So we have to subtract this whole function. So when you're doing subtraction, that means you're subtracting everything here. So it's going to change the signs on each of the terms. So we'll get this. And now when I combine like terms, I would end up with this as the answer here. Same domain. They overlap everywhere. So they would have the all real numbers as the domain. When you do the subtraction, this is what you get. All right, so let's take a look at the next page, which talks about the composition. Now, composition is different than the previous page. Composition is represented by this symbol here. And this symbol here looks like a circle, and it makes it look like F circle G, or the word fog, and it's read as F composite G. So this is read as F composite G. And because it has the X there, it would say F composite G of X. Or you can write it like this. You take the function G of X and you put it inside the input of F. Then it tells you the domain. It says the domain of the composite function is the set of all x such that x is in the domain of G. And then that G of x is in the domain of F. And we'll look at that in a moment when we take a look at the next problem. So here we have two functions, and it asks us to find F composite G of X. So when you see this circle notation, that means composite. It is not the same as multiplying. It is F of G of X. And when I'm doing a problem like this, I want to work from the inside out. And so I'm going to put, I see that I have G of X here. So that this is G of X. And I'm going to input that into, that's going to be my input into F. So into F, I'm going to put 2x squared minus x minus 1. So that is what I input into F. So what is function F? Function F is here. You take 5 times the input and then add 6. But now our input is function g. So that is what's going to go in my blank spot. And then it's just a matter of simplifying. So the 5, because it's in front of this expression, gets multiplied by every term in the expression. So I have 10x squared minus 5x minus 5 plus 6. And then I look, do I have any like terms? And I do. I have the negative 5 and the positive 6. And so that is what I'm going to add together. And so my final answer here would be 10x squared minus 5x plus 1. So this would be the composite of those two functions. And it matters which way you write it, because if you write it g composite f of x, then you're taking f of x and putting it into the function g. So that is going to give you a different answer than this. Now, the domain here, if we go to the next page here, the domain has to follow these rules. If x is not in the domain of g, it must not be in the domain of f composite g. And they wrote out circle here. That's just the description. This is the same as writing this, right? And then second, any x for which g of x is not in the domain of f must not be in the domain of f composite g. So in this previous problem, here the domain, both of these started with all real numbers, so the domain of the composite function would be all real numbers. It's when we get to a problem like this is where we have some exclusions from our domain. And so we're going to look at that problem in the next video.